Okay, you guys, I better read the. Whoa. I better read the question. So what's the minimum order of the Taylor polynomial required to approximate the following quantities with an absolute error no greater than 10 to the negative? I'm on the wrong question. Sorry. Use the remainder term to estimate the maximum error of the following approximations on the given interval. And the error bounds are not unique. Maybe this is a decent one. So you guys, I gotta confess, is he forcing me to use the remainder theorem? You know, he really is, but I gotta confess, you guys, you do have alternatives. I mean, this is gonna be an alternating series. You might not be able to see it, because the author only gave you 2 terms. But technically speaking, this ends up being an alternating series, and you can generate it just by the typical geometric series. You don't have to use Taylor polynomial representation. But I think what the author meant with this question is the following. He's saying, the output of this function, I took my glasses off. Is this correct?
Yes.
Could be interpreted as this power series. You guys just humor me, do you agree?
Yes.
Centered about x equals, it definitely is 0.
Is that because the middle is between negative 0.2 and 0.2?
Actually, no, I wasn't even looking at that, but good point. I was merely looking at how this is not like an x minus 3.
Okay.
And this is not like an x minus 3 quantity squared. That's what I was proving. And that being the case, let's generate it. I think the very first term is going to be nothing more than my first derivative. Oh shoot, I can't. I need those derivatives. Darn it. Can I use the middle board? Piece of scratch paper. Here's my m. Here's my first derivative. Here's my second derivative. Well, that's all I need, right? Just going to the second derivative. That's all I need, right? Just going to the
No,
second.
you gotta go to the
Yeah, I
third.
don't think it is. I mean, it may be good enough to generate those first 2 terms over there, but since I'm going to use a remainder theorem, I do think I better take a brief moment and compute the next derivative, which is that a positive over 1 plus x cubed? I'm just a little nervous today with my arithmetic. I'm stalling. And if you guys are okay with that, let's plug everything in. Because I think what I generate is this first derivative evaluated 0 plus the first derivative evaluated 0 times x plus the second derivative evaluated 0 all over 2 factorial times x squared. I misspoke. I meant to say those first few terms approximates the output of that function, which approximates this infinite series. And let's plug in what we know. F evaluated 0 is, oh, how nice. F prime evaluated 0 is positive 1 times x. There's my next term. And f double prime evaluated 0 is going to be, is that a negative 1? Over 2 factorial times x squared. Oh, thank goodness, you guys. It's the same thing he got. I was just generating out of thin air. And I've lost a question. The next question is, how accurate is this over the interval from negative 0.2 to 0.2?
Yes,
Well,
or maximum error. They want you to compute the maximum error.
And so I think the maximum error used is going to be bounded above by m times, or I misspoke, m divided by my n plus 1 factorial times x minus a, which is 0 in this case, raised to the 3rd power, where I confess m is simply an upper bound for the 3rd derivative function evaluated x for all values of x in the interval. Help me, you guys. Is it negative 0.2 to 2? 0.2? Is that
Yes,
it?
yeah.
Okay. Oh, but shoot, I messed up. I don't know where the 3rd derivative function is. Oh, here it is. Somebody panic and say something about this function over this interval. Can anybody say anything? Yes, it is. I agree. Can you say more?
It's monotonic.
I think it is. Which direction?
Down.
You're not saying that with confidence.
Down.
Thank you. I think it is strictly decreasing. Do you guys agree? How would you figure that out?
The bottom is increasing with that bound and going towards 0.
Yeah, that's one way. That's the way I initially answered the question in my head. I simply graphed this because it was easy. And we know what it looks like. Then I graphed this. Oh, shoot, same thing, right? Just scale change along the y-axis. Oh, and then I graphed this. Sorry, it was so slow. But that is a graph of this beast just translated when using left. Clearly monotonic, clearly strictly decreasing. If you don't like the way I'm speaking, don't listen to me. No writing. If I were to compute the fourth derivative, I get a negative sign up top again. And so all values of x bigger than -1, I think my fourth derivative function is going to be negative, which means the previous derivative, the third derivative, is strictly decreasing from -1 on up. So a couple different ways to look at it. But if this function is strictly decreasing and is strictly positive, I think the biggest the third derivative function can get over this interval is how about there? Is this decreasing? And so what I'm going to do is I'm going to take that output, my third derivative function, and I'll evaluate the left-hand point. And I end up getting 2 over I don't know. You guys are making me drown again. I give up. Didn't even do the calculator. What's 2 divided by 0.8? 0.8 to the third power. I've gone this far. Can I just finish?
It's 3.90625.
That being the case, actually, since I'm in front of the entire class today, you guys, can I be this lazy? I don't want you to be, but just because I'm beating that clock.
So what the book does for all of these, not just this one, is they say that since that value is less than 4, they just set it equal to 4. And they do that for all of them. So if it's something that's like 1.6, they call it 2 and state that since it's less than 2,
They do
it's
not.
just, they do too, for all of them. I checked the
They
answers in the
don't.
back and I was looking at yours. I was looking at your video, or your lecture on this, and that's where I was confused.
Bradley,
Because they keep
I
doing
don't like
that.
doing this. I'm only being
Yeah.
honest. I didn't want to lecture today, so I'm trying to beat the clock, and I'm being really lazy.
Yeah.
I certainly don't want you doing that then. Okay, let me back up. I haven't answered the question yet. We're trying to get an upper bound on how far off our approximation is, using the first few terms, to approximate this infinite series. Don't you want the smallest number possible? To tell you how accurate you are. So I think if this were like a 1.6, you jump all the way to 2, that's really stretching it. That makes me nervous. So Bradley, if I created a question like this in my lecture last week, I hope I didn't go that far.
Let's see.
So is this saying that our error is off by 4 or off by
No,
4?
to be honest with you, I have not answered the question yet. I was only taking a small piece and finding out what M was, and now I'll finish to answer the
So
question.
check this out. See where they do that right there? And they equate it to say that it's less than 2.
Gives me the shivers.
They do that on all of them.
So, do you guys, am I going to make you upset by saying, don't do that?
No.
And you know what? I still haven't answered the question. I got an idea. Let's go ahead and plug in what we know. I found my M value, now you'll make me feel guilty, over my 3 factorial, times x to the third. Oh, shoot. What is x? X was it 0?
Yes.
Yes.
Was it?
No. Yes.
See, I thought my a was 0. What's x? I agree with that. See, I think x could be chosen anywhere within this interval. And away from 0, what's the biggest distance I possibly have? 0.2. I think anywhere you are in this interval, the distance you are from where the a value is, that's 0, can be as big as 0.2. Might be less, but it could be as big as 0.2. And so I will substitute 0.2 in for x. Do you guys mind if I don't finish? This just is some number you might want to calculate in a calculator. And that gives you an upper
So-
bound on how far off there is error in using R sub 2 to approximate.
So if
that
it were,
infinite
say, in
series.
between like 5 and 10, then like 2.5 would be the biggest value that you could
As long as
choose?
the power series was centered about x equals 7.5.
Okay,
You said 5 to 10, didn't you?
yeah.
Yeah. So can I say it differently, guys? If this is really the x minus a cubed, then you want to talk about the biggest deviation you can be away from a with any x value. And let's see if you guys are ready for this. What if I change this to a negative 0.3? That's still a 0.2. What are you going to use for x?
0.2.
I can't hear you. I think 0.3. I think that's the biggest distance you can be away from the center, which is 0 itself.
Oh, 'cause I thought you
Okay.
wanted the biggest distance in absolute values, meaning from kind of like our delta epsilon thing, you want to use the lesser of the two.
And I don't think it's the same case anymore, because over the interval from negative 0.3 to 0.2, centered about x equals 0 for this power series, I think the greatest distance from 0 I could be for any value that's in that interval is positive 0.3 units.
So the biggest number within the interval.
You guys, I'm just cheating. I'm trying to change the example so it's more complex.
Okay, that makes sense.
So if we're not rounding up, would we just use the exact value, like, how did?
You know, Randy, you got a good point. I think my answer could be even tighter by using that. But even if you wrote decimal expansion, chose several places out the decimal position, I think it's better than that.
Okay, but if say like we got 1.6, we would just use whatever we got to generate that.
Sure, that would
1.6
work.
Place.
That would be the best thing to do.
Okay.
I agree.
And as far as choosing the value to plug in, since in absolute value the negative and 0.2 is the same as the other, what are you going to plug in? Or I mean, if it's really absolute value, then it's going to be positive either way.
Yeah, you should think of it always being a positive distance. It's the greatest distance you can deviate from the center of the power series expansion over that interval. And since clearly the center of this power series expansion is about x equals 0, the question really is this. Anywhere in this interval, how far off are you? Anywhere in this interval, what's the greatest distance you could be from x equals 0?
Okay.
And I think the answer is positive 0.2, because you and I always have a positive connotation with
So I
distance.
guess my question was more along the lines of if it was the x minus a cubed in this case, and you had an a value,
Hmm.
then you would choose whatever was the lesser of the two from.
I hate to
on
say
either
lesser.
side.
Can I
like-
change this example to really address this?
Okay.
Let's do this. You guys, can I cheat this badly?
Is that 2 in the exponent?
So I can't cheat that badly, as I was saying. So Randall, clearly my A value is a power series centered about x equals 3. And I want to answer the same kind of question without going through all the details. I want to tackle one issue you have, which is, what do I plug in for x? Because I think over this interval, centered about x equals 3, the deviation to the left-hand side is 0.1. The deviation from 3 on the right-hand side is going to be 0.01. What's the bigger distance, on the left or the right?
Right.
I think the left. Because I'm deviating 1/10 of the units plus 1/100 on the right. So if I drew a number like graph.
yes.
Here's my
Yes,
3.
yes.
I think 3.01 is
I-
so much closer to 3 than 2.9.
Yeah.
And so what I would have plugged in for the x, Randall, watch. Sorry. What I would have plugged in for x over here would be my 2.9, not my 3.1. Because if I plug in 2.9, that gives me a difference that's as big as 1/10 in absolute values, by the way. I really do want the absolute values. And that's what I would choose to plug in for x. Is that logical?
Where did you come up with the 2.9 and the 3.0?
I made it up out of thin air. I asked this. I asked, how far off could the first couple terms be over this interval?
Okay.
And I just wanted to see if you chose the right thing to plug in for x. I put the absolute values in there because now I'm positive or negative on either side. The other example I wasn't.
So So it's whichever's greater in terms of absolute value.
Yes. And if you put in a small one, it means that error on the right-hand side might not be big enough, and you might have an error that's even stronger perhaps. That's why it's so important. You want to choose the largest deviation from A that you can.
But-
Unlike the doubles.
Okay, but say that you had a 3.1 there instead of 3.01, then would it even matter, or?
Yeah, now it's just gonna be 0.1 period. It's the same deviation left and right, isn't it? So I wouldn't worry about that. Jerry?
On three, they ask you to find the upper bound for the error and the series expansion for sign, and they give two terms of the sign. And the book assumes that it's an order 4 quantum, and you always assume like it's the best case and like it's the highest order quantum or inner series that is possible, or
You gotta go to the next actual term.
Yeah, and the next actual term that was missing was 4.
but like they give x minus or x cubed over 3, that could be 2 or 3. So you just
Oh, I see your point.
yeah.
Yeah, but still, I do still think that's a third degree polynomial period. I call the R sub 3.
Okay.
And therefore the error would involve the next higher derivative.
Do we always start our count at 0?
Yeah, I do. No,
Okay.
I take that back. You don't always have to. I do. Even if you don't, who cares? I think the R sub whatever is really the power to which you have as a
As an
term
exponent.
in that expansion.
Okay.
So who cares if you start at n equals 0, n equals 1, or n equals 17? I think P of 2 is referring to the second degree polynomial. R2 as its remainder.
Okay.
Did you want to do more?
Maybe just one, because the book does guess and check for this answer.
Which number are you looking at?
number 59. And so I was just seeing if there's an algebraic way of doing this that works. 'Cause
The other books are doing the same thing.
Now, I think number 59 is a little bit different.
okay.
And I have to confess, I hate to call it guess and check, but I have to confess, I don't have a more sophisticated way. Here's why.
Okay.
Do you guys agree with this?
Yes.
And the other term is this. Now, what if I wanted to approximate e to the 0.5? Wouldn't I get this? And that being the case, if I were to use the first n terms, to approximate,
Wouldn't it be e to the or negative 0.5? Because it's the question is to approximate e to the negative 0.5.
Oh, is
Or
it?
would you start by doing the series or the power series for e to the negative x and then plug in
Oh my gosh.
0.5?
Okay, so what your author's doing is making the question a lot easier.
Okay.
Hold on, I'm a little slow. I just get my sign straight. Got it. And Bradley, I'm trying to rush.
Yeah.
The question's something like that, isn't it? Even though I might have my numbers wrong.
Yeah, I just want to.
Because this is an alternating series, I don't have to be sophisticated. I'm just going to take the first unused term in absolute values and make sure it's no bigger than 0.001. But I think the first unused term in absolute values is going to be this one. I will simply set that less than or equal to my 0.001. And I'll let my math D skills solve the equation, the inequality for me. Oh no, look. Math T skills fall apart. I can't solve that equation for n. Except in the exponential position, which makes me happy, I'm thinking logs. But because it involves a factorial there, I don't have any algebraic technique to isolate n that inequality. Here's where I give up. I'm serious, I give up. I go out in this expansion and I compute this number, see what it is. And I compute them until all of a sudden I get to one that's going to be less than that, and I know I'm done. The first previous n terms are what I use to approximate.
So you actually do use guess and check there?
I hate to say guess and check. I'm just evaluating some terms out there. But Bradley, do you see
Okay,
why I'm doing
yeah.
it that way? Because I can't solve algebraically for n with that mess. Sometimes I can.
Because I just went through and plugged in values for n.
That's what I would do.
Yeah, just up until I got
Until you
to
find
that
the
point, yeah, and then I just, alright, well, it's
But you
not-
understand why I'm saying you just have to go that route.
Okay, yeah.
Because the algebra falls apart.
So are there, other ones, well, I guess they all use factorial, right?
Oh, no, not necessarily.
When you get to
There's
that
a lot of
point.
series that don't involve factorials. A lot of power series.
Yeah, but isn't like the M answer there, always going to involve a factorial?
Based on the definition of the.
Based on the definition of the remainder theorem, yeah.
chemistry.
Not if your nth order derivative or n plus first order derivative had coefficients that were factorials. They cancel with the one downstairs.
Oh,
Right?
okay,
So I can think of a lot of examples where I don't necessarily have factorials.
okay.
So you guys, can I talk about something?
Yeah.
Let's you and I talk